So, have you ever actually wondered where humanity ranks on a literal universal scale? Like if an advanced spacefaring civilization were to drop by Earth and hand us a galactic report card today, what would our grade actually be? Well, today we are diving into a deeply fascinating piece of research from the California Institute of Technology that calculates exactly that. We're going to map out humanity's cosmic scorecard, evaluate our entire energy evolution, and predict exactly where we're going to stand in the year 2060.
All right, here's the hook, right up front. 0.7276. Dramatically precise, isn't it? This highly specific number is humanity's current score on the cosmic scale. But what does this number actually measure? How in the world did we earn it? And probably most importantly, what is it going to take to raise it?
Okay, let's dive into this. Here is our roadmap for today. First, the cosmic energy scale. Second, drivers of human progress. Third, predicting the year 2060. Fourth, the fossil fuel trap. And finally, number 5, the nuclear fusion wildcard.
So, kicking things off with Section 1, the cosmic energy scale, and how we actually measure the power of an entire civilization.
You know that incredibly precise score I just mentioned? Well, that comes straight from the Kardashev Scale. Proposed by a Soviet astrophysicist named Nikolai Kardashev back in 1964, it classifies a civilization based on a single, brutally honest metric: total energy consumption. It's pretty straightforward. A Type 1 planetary civilization can harness all the energy reaching its home planet. Type 2 harnesses the total energy of its host star. And Type 3? Well, they control the energy of their entire galaxy. Later on, the legendary Carl Sagan came along and refined this with some logarithmic math to create a continuous sliding scale based on our energy consumption rate in watts. And that specific formula is exactly what gives us our current index. The researchers actually put this so beautifully in their paper. They wrote, "Humanity is but a mere sapling that has just budded." I mean, think about that. We haven't even reached Type 1 yet. We're sitting at 0.7276. We are literally in the incredibly early infancy stages of our cosmic journey. And we're going to need massive, complete paradigm-shifting leaps in how we generate and use energy just to take our first real stride onto the scale as a true bona fide planetary civilization.
Moving right along to Section 2, drivers of human progress, where we decode the actual variables of our future.
Now, to forecast our civilization's progress, the researchers didn't just, guess. They essentially used advanced artificial intelligence as a crystal ball. Specifically, they deployed 2 powerful machine learning models, Random Forest and ARIMA. They fed these models decades of historical, multidimensional data across 66 different countries. We're talking everything from economic indicators like GDP and population to climate variables like temperature, CO2 levels, and even water vapor. The AI's entire job was to dig in and find the hidden patterns in how we consume energy.
Now, what's really interesting about this is the definitive ranking of what actually drives our progress. Using a data science tool called SHAP values, which basically measures exactly how much a specific variable impacts an outcome, the AI revealed that the economy is absolute king. GDP overwhelmingly drives our energy consumption, carrying an impact factor 6.4 times greater than the runner-up. Total population and urban population take the second and third spots. Amazingly, environmental and climate parameters currently show very, very low impacts on our energy consumption. So basically, economic growth is the main engine demanding more power across almost all areas of modern human life.
All right, Section 3, predicting the year 2060, getting into the actual machine learning forecast.
And here we go, the big reveal, 0.7474. That right there is our projected Kardashev score for the year 2060. Now, compare that to our current score of 0.7276. That is painfully incremental progress, isn't it? I mean, after 4 more decades of non-stop human innovation, urbanization, and rapid economic expansion, we barely moved 0.02 of a single point up the cosmic scale.
Let's actually break down what that means by the numbers, because it's a bit of a paradox. The forecast projects that by 2060, global energy consumption is going to reach a staggering 928 to 940 exajoules. That is an absolutely immense amount of power, literally the equivalent of burning billions of tons of coal. It represents a massive total growth of over 50% in our energy use over the next 40 years. But here's the catch. Because the Kardashev scale is logarithmic, that colossal 50% jump in real-world energy use only yields a remarkably humble average annual growth rate of about 0.077% on our Cosmic Scorecard. So we're generating a tremendous amount of absolute energy, but relatively speaking, we're barely moving the needle.
Which brings us to the central conflict here in Section 4, the fossil fuel trap.
This is essentially the dramatic speed bump in our evolution.
So the crucial point we have to understand is this. An alarming 80% of our current energy consumption still relies on fossil fuels. These are, by definition, anachronous and entirely unsustainable methods of extracting energy. And yes, while clean and renewable energies are super promising, the researchers note that they currently face limitations, a certain immatureness, if you will, that prevents them from completely dominating and replacing fossil fuels over these next few crucial decades.
And the data delivers a pretty harsh reality check. Because fossil fuels are a finite and ultimately limiting resource, our Kardashev index slope is actually actively decreasing. The researchers plainly state that if we stay in this current energy structure, if we essentially remain stuck in the fossil fuel trap, it may take human civilization literally millennia just to achieve Type 1 status. Without a massive structural change, our cosmic progression is just going to grind down to an absolute crawl.
But it's not all doom and gloom. Let's get into Section 5, the Nuclear Fusion Wildcard, and how we might unlock the next industrial revolution.
To see what a way out looks like, the researchers ran a simulation to see what happens if we pull off a massive technological breakthrough. They juxtaposed two different futures for the end of the 21st century. In the first scenario, without nuclear fusion, we stagnate at roughly Type 0.7534 by the year 2100. But with the successful commercial deployment of nuclear fusion, our score rockets up to approximately Type 0.7719. And while that might still sound like a small decimal, on a logarithmic scale, that is a massive structural deviation in our entire evolutionary trajectory. The projected curve brilliantly illustrates this exact deviation. You have one path, which is our current sluggish, business-as-usual trajectory without fusion, and then you have this sudden, hockey stick exponential growth curve that nuclear fusion could unlock. It completely alters the angle of our ascent. We're talking about something that isn't just a slightly better battery, it is a fundamental, ground-up rewriting of our entire energy capacity.
So, to summarize the research here, nuclear fusion acts as the ultimate catalyst. It generates nearly inexhaustible, completely pollution-free energy. Most researchers in the field foresee its actual, scaled-up deployment happening right around the year 2060, mirroring the kind of explosive, society-altering growth we saw during the Second Industrial Revolution. It is the exact wildcard we need to break humanity completely out of the fossil fuel trap and put us firmly on the fast track to becoming a true Type 1 civilization.
So the numbers are pretty clear. By 2060, we're going to have taken small, incremental steps, reaching 0.7474. But the real test of our civilization is whether we can actually innovate our way out of the fossil fuel trap and finally unlock the stellar power of fusion. We are a sapling that has just budded, but the potential to reach the stars, well, it's written right there in the data. So the ultimate question remains, when will humanity finally reach Type 1? Thank you so much for exploring this data with us today. Keep questioning, keep learning, and I'll